Questions 21 through 25 on the 2015 grade 12 AMC 12A. A circle of radius r passes through both foci of and exactly 4 points on the ellipse with the equation x squared plus 16y squared equals 16. The set of all possible values of r is an interval a to b. What is a plus b? Let's draw a diagram and let's try to explain this. First, let's just concentrate on this ellipse. So this ellipse has the equation x squared plus 16y squared is equal to 16. When you set y to 0, we can quickly figure out x will be plus or minus 4. So this will be 4 and this will be minus 4. When we set x equal to 0, we will figure out that y is equal to plus or minus 1. So this will be 1 and that will be negative 1. Now the foci are somewhere here. Let's say this is F for foci, and this is F right here. And there's a property in the ellipse shapes that the foci can be calculated as follows. I'll just label it first. Let's say it has the coordinates C0. You use Pythagoras, draw a line from that point where it touches the y-axis to the foci. And this, of course, is 1 in terms of length. This is C, and I'll call this D. And the very important property, ellipse property, and I think that's the key to this question. If you don't know this, I don't see how you could solve it, is that 2D is the equivalent of the entire length from one end to the other on the x-axis. And in our case, that's 8. So that means D is equal to 4. So once D is equal to 4, using Pythagoras and that triangle, we can easily figure out the value for C. So 1 squared plus C squared will be D squared, which is 16. C squared is 15. C is the root of 15. So now let's start talking about the circle. They want a circle. Well, the first scenario, of course, is if you have a circle that goes directly through the foci like that and hits the other foci. So let me draw that again, just like that, matching the condition of the question, which is that it passes through both foci, this one and this one, and it passes through 4 points on the ellipse. So 1 point, 2 point, 3 points, and 4 points. That matches. And what is the radius of this? Well, the radius of this is from here to here, which is C, and C is root 15. So if we were to write what r is, r can be root 15. That's part of the interval. Now we have to figure out the next scenario, which is what is the upper limit of r. We found the lower limit to be root 15, but what is the upper limit? Okay, well, what if we have a circle that just touches down there, like that? Is that going to be sufficient? Well, it passes through both foci, that's fine, and it passes through 2 points here, but unfortunately it only passes through 1 point there. It has to pass through 4 points on the ellipse. Okay, not a problem. We'll just draw the circle again, but this time notice that we'll draw the circle just below, just ever so below, because we want to figure out what is the absolute upper limit of that. So, I mean, here you can see as small, but imagine that it was so microscopic that it was almost negligible, just small enough so that it could pass through 4 points. 1, 2, and then of course these ones are no problem. So this distance from here to here, from this blue line to this orange line, you can consider it negligible, as small as possible right there. Okay, so now that we've talked about that, let's talk about the radius. Now let's just say the center of this circle that I just drew is right here, approximately. Not really sure where it is, but let's just say it's there. Now if we draw the radius of that circle, it would be from there to there. And if I draw a line from there to the edge of the circle, that is of course also the radius. Now let's label this now. This is of course radius. From here to here is C. And if this is the center right here of the circle, I'll just call it center. The x-coordinate is of course 0, but the y-coordinate, I'm not sure, so I'll just write y. And I'm going to get rid of that 1 there because I'd like to label the distance from the center to the x-axis as y. So now using Pythagoras on this right triangle, I can figure out a relationship. C squared plus y squared is equal to r squared. Well, c squared is 15, so that's 15 plus y squared is r squared. But I can also figure out a relationship between y and r. From the center to the edge of the circle is the radius, of course, but that can also be represented as y plus this distance, which is 1. Now you say, well, it's a little bit more than 1, isn't it? And the answer is yes, but we're doing it in a way so that it's so small that it's negligible. So we can pretty much call this distance 1. So that means that r is the equivalent of y plus 1. All right. So now we just plug that into here and off we go. So we got 15 plus y squared is equal to y plus 1 all squared. So this will be y squared plus 2y plus 1 is 15 plus y squared. The y squareds cancel. You get 14 is 2y and y is 7. Since r is y plus 1, r will be 7 plus 1, which is 8. And that is the upper limit of the radius. So our interval RAB is root 15 and 8, and they want you to find a plus b. Well, a plus b will be just root 15 plus 8. And that for number 21 is choice D. For each positive integer n, let s at n be the number of sequences of length n consisting solely of the letters a and b with no more than 3 a's in a row and no more than 3 b's in a row. What is the remainder when s 2015 is divided by 12? All right, well, we need to first figure out a few values of s, and then we can take it from there. So let's first figure out s at 1. Well, s at 1 means you only have really two choices, either an a or a b. So s at 1 is obviously equal to 2. There's two ways of doing that. S at 2. Okay, there's 2. Now I can have 2 a's, 2 b's, or a, b, and 2 b's like that. So this is obviously 4. S at 3. Okay, I can now have 3 a's like that. I can have 1 b, and there's 3 ways of doing that. B, A. I can have 1 a and 2 b's. So A, B, 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 A, B, and B, B, A. Or I can have 3 b's, B, 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 like that. So S at 3 is 8. S at 4, let's figure that one out. That is going to be either 3 a's and a b. So there's a few ways of doing that. B, A, B, A. Or you can have 2 a's and 2 b's. So A, B, B, like this. And so on down. And this is 14. Now, when I get to S and 5, I don't want to list them. It's very time consuming. So let's talk about how to do it without listing them all. Well, let's first talk about how many arrangements there are. We can't have 5 a's in a row because the rules say you can't have any more than 3 in a row. But you can have 4 a's and 1 b. And that can be written like this as long as there's not 4 a's in a row. So you can put the B in the middle, or you can put the B in between. So like that. So there's 3 ways of doing this. Now you have 3A and 2B. So now instead of listing them, I'll use choose notation. So from the 5 spots, I can choose 3 to place the A's. And from the remaining 2 spots, I can choose 2 to place the B's. And this is 10. So same thing with 2 A's and 3 B's. From the 5 spots, I can choose 2 to put the A's, and from the remaining 3, I choose 3 spots to put the B's, and that is 10. And then the 1A and 4B category is very similar to what we have up there. And that is 3. So adding these up, you get S at 5 is 26. And you can keep going, S at 6, S at 7, and so on, however long you need to go to figure out a pattern. And that pattern, which in my opinion is a bit challenging, considering how time-consuming it takes to actually get each of these S's. And that pattern is as follows. S at n is equal to S at the 3 previous S's. So S at n minus 1, S at n minus 2, and S at n minus 3. And if you do a really quick test, for example, S at 26, S at 5 is equal to the previous 3, right? So what is it? 14 S at 4 plus S at 3 plus S at 2, which is 4, and that is indeed equal to 26. So challenging, but of course we're late in the contest, so of course it will be. Now what we do is we make a list of certain possible values of S using this formula, and let's see if we can get some sort of a pattern. And in this table, this one I will put S at n. In this column we will put the remainder when S at n is divided by 12. Here we'll put the remainder when S at n is divided by 3, and here we'll put the remainder when S at n is divided by 4. And if you've done enough of these questions, you'll sort of understand why. But let me just concentrate on this part first, and then I'll explain the whole 3 and 4. Well, S at 1, some of these we already did, is 2. S at 2 is 4, and I'll just fill out this part of the table. So this table I got entirely from this formula right here, just adding the sum of the previous 3, basically. So when you would take the remainder by 12, and you take the number, divide by 12, and what do you get as the remainder? Let's see, you get 2, 4, 8, 2, 2, 0, 4, 6, 10, 8, 0, 6, 2, 8, 4, 2. Well, do you see a pattern? I don't. So because there's no pattern even after 16, that's why we have to do this part here. It's easier to do it if you break it up to get a pattern. Now let's see what happens when we divide by 3. What are the remainders? We get 2, 1, 2, 2, 2, 0, 1, 0, 1, 2, 0, 0, 2, 2, 1, 2. Okay, there is a pattern. Now, I only limited it to 16 just to save time, but trust me, this is the pattern. It's a 13 deep pattern. So the period of this pattern, I guess, is 13. Every 13, it repeats. And as you can see, it's starting to repeat, right? 2, 1, 2, just like 2, 1, 2 there. Now let's do the same thing, but this time for 4. It's going to be 2, 0, 0, 2, 2, 0, 0, 2, 2, 0, 0, 2, and so on. 2, 0, 0, 2. So this one is much easier to recognize. It's obviously just 2, 0, 0, 2. So that period is 4. That pattern has a period of 4. Okay, now we have to figure out what is 2005? That S, or 2015, yeah. Well, we certainly don't need to figure out what it equals. That would take forever. But we can use these to figure out what is the remainder. Well, divide 2015 by 13, and let's see what we get. 2015 divided by 13 to try to figure out which one of these will be the remainder. Well, 2015 divides evenly. So that means every 13th will be the remainder. So S13 was right here. S2005 will also have 2 as its remainder. All right, now let's go over to the remainder by 4. 2015, when you divide by that period, which is 4, it doesn't divide evenly. It's 503 with a remainder of 3. No problem. That just means that if you go every 4, it's going to be 2, right? But we just have to go another 3. So 1, 2, 3. So you get to 0. So that 0 is going to be the remainder when you divide by 4 for this value, S 2005. Okay, now we are pretty much done with the question. We just have to now figure out which one of the answer choices are right. The answer choices are 0, 4, 6, 8, and 10. What this means is that we want a number that when you take the number and you divide by 3, the remainder is 2. And a number that when you take it and divide by 4, the remainder is 0. So let's figure out for each of these. Remainder when dividing by 4 and 3. Well, this is 0, 0, 1, 0, 0, 2, 2, 0, 1, and 2. So which one has a remainder of 2 when divided by 3 and a remainder of 0 when divided by 4? The only one is this guy, as you can clearly see. Remainder of 2 when divided by 3 and a remainder of 0 when divided by 4. So 8 is the answer to this question. And that would be 22 is D. Let S be a square of side length 1. 2 points are chosen independently at random on the sides of S. The probability that the straight line distance between the points is at least 1/2 is A minus B pi divided by C, where A, B, and C are positive integers, and the greatest common divisor of A, B, and C is 1. What is A plus B plus C? All right, well, we've got a few scenarios here. The first one is, I'll just draw them out. We've got one square, we've got another square, and we've got a third square. Now, the first one is a scenario where the 2 points are on opposite sides. So we choose a point here, and then we choose a point on the opposite side. Now, when we draw a line between those 2 points, I hope you can clearly see that it's always going to be greater than 1/2. It's actually going to be greater than 1, because this square has side lengths 1 and 1 all the way around. So if I have a point here and a point here, even if I have them completely opposite each other like that, and I draw a line, the minimum distance is going to be 1. And if I draw a line on a slant, it's always going to be greater than 1. So the probability that that distance between those 2 points is greater than 1/2 and I'll label that D here. The probability of D being greater than or equal to 1/2, which is what the question is saying, at least 1/2 is 1. So that's pretty straightforward. And this scenario, this first scenario, happens 1/4 of the time, right? If you choose a point here, the second point can be either here, 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 or here. But I put the second point on the opposite side here, so that's 1 out of 4. So this happens 1 out of 4 of the time, of the total. All right, so that's the first scenario. The second scenario is when both of the points are on the same side. So for example, this is one point and this is a second point. And we want the distance to be greater than or equal to a half. So points are on the same side. And we have to figure out what is the probability that that distance is greater than or equal to a half. Well, that's going to happen basically if there's a couple scenarios. Let's say I call this guy A and I call this guy B. Well, clearly for this line AB to be greater than a half, B has to be greater than A plus a half. Right? If A, for example, was 0, let's say this represents 0, then B's got to be at least a half. If B was, say, if A was, say, here, which is 0 point whatever, 2, let's say, then B's got to be at least 0.7. See what I mean? So that's where we get this inequality. Another inequality is the opposite. If we reverse the conditions, we could have them as B less than or equal to A minus a half. So for example, if we reverse them, so I put A here, they're on the same side, and B is here, and A, say, is 0.8, then B has to be less than or equal to 0.8 minus a half, which is 0.5. So B has to be less than or equal to, what's that, 0.3? So B has to be less than or equal to 0.3, so let's say it's 0.2. And that indeed would make the distance from A to B greater than or equal to a half. So those are the two inequalities that must hold true. Now those two inequalities, we have to graph them. And when we graph them, it will be a scenario where we can figure out the probability. So if I graph these now, I'll just make a square here where this represents A and this represents B. So this right here, B is greater than or equal to A plus a half, is essentially the midpoints, the line between those two midpoints. So like this. And then the other one where B is less than or equal to A minus a half is the line between those two midpoints. So this scenario right here. And the area of those two represent the probability. So this whole thing was 1, so this is a half, this is a half. So the area pretty much is 2 times those two triangles, and each of those triangles is 1/2 base times height, where the base and the height are both a half. So this is a quarter when you multiply it all out. So this probability in here is a quarter right there. Okay, and this happens, this scenario happens 1/4 of the time of the total. Right, because if you put something on one side, you have 4 possible choices for the second point. You can either put it here, 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 or here. I've chosen to put it on the same side, so there's only one out of the 4 possible places. So that's why it's 1 out of 4. All right, now we get to the last part. And the last part is when the points are on adjacent sides. So for example, one point is here and another point is here. And I've got to make sure that the distance between those 2 points is at least a half. So if this is A and this is b, I've got to make sure that distance is at least a half. So the probability of that, of d being greater than a half, is what I have to now figure out. All right, well, if this is a and this is b, and this is obviously a right angle, I can use Pythagoras. A squared plus b squared is equal to 1/2 squared. So a squared plus b squared is equal to 1/4. But how am I going to graph that now? I was able to graph it on the previous one pretty easily, but now what's this? Well, I hope you can recognize that this here is really the equation of a circle. It's the circle where a and b are obviously between 0 and 1. So we're only looking at the first quadrant, where this is a and this is b. And the radius of the circle is a half. So first let's draw in our boundaries, which would be 1 and 1. And then we have to draw in a circle that has a radius of a half. So something like that. And we want the probability as follows. We want anything that is equal to a half, but also what's going to be perfectly valid is if it's greater than a half. For example, if I'd made a line like this, or if I made a line like that, that's fine. So really what we want is a plus b is not just equal, but it's actually equal to or greater than. So it's like this. Now on this graph, if a plus b was equal to a half, it'd be just that line right there, that part of the circumference. But it's greater than, so it's basically this whole region right here. And that is the area we have to figure out. Well, that area will be as follows. I'll do it over here. So now we have to combine our findings. Our probability will be this 1/4 times this 1 plus this 1/4 times this 1/4 plus this half times this 1 minus pi over 16. So now if we combine, we get 1/4 plus 1 over 16. Multiplying this out, we get 1/2 minus pi over 32. Get a common denominator. It'll be all over 32. This will be 8 plus 2 plus 16 minus pi. This becomes 26 minus pi over 32. And that is of the form a minus b times pi over c. So that means my a is 26, my b is 1, and my c is 32. Greatest common divisor of 26, 1, and 32 is indeed 1. So now all I have to do is figure out the sum a plus b plus c, and that is 26 plus 1 plus 32, which is equal to 59. So 59 is the answer to this question, and that would mean 25. The answer is A. Rational numbers a and b are chosen at random among all rational numbers in the interval 0 to 2 that can be written as fractions n over d, where n and d are integers, with d between 1 and 5 inclusive. What is the probability that the cos of a pi plus I sine b pi all to the 4th power is a real number? Well, it's a probability question, so as always it's a fraction. And first we will try to concentrate on the total number of cases, and then later we will figure out the numerator. So first we have to make out all the possible A's and B's. So all the possible values of A or B. Now keep in mind that D is between 1 and 5. So we have to make numbers so that they are between 0 and 2, but they have to be less than 2. That's what that symbol means, that bracket. Okay, when D is 1, the only such numbers where n over D is between 0 and 2 are 0 and 1. When n is 2, the only such numbers are 1/2 and 3 over 2. When D is 3, we get 1 over 3, 2 over 3, 4 over 3, and 5 over 3. When D is 4, 1 over 4, 3 over 4, and 5 over 4, and 7 over 4. And remember, we have to have distinct numbers. I skipped over, for example, 2 over 4 because that's the same as a half. So it's the same number. And then when D equals 5, we have 1 over 5, 2 over 5, 3 over 5, 4 over 5. We skip over the 5 over 5 because that's just 1. 6 over 5, 7 over 5, and that's 8 over 5, and finally 9 over 5. Okay, so how many did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got 20 for A and 20 for B. So 20 possible A's and 20 possible B's. So there'll be 20 times 20, which is 400 possible combinations for A and B. So if we look at that probability, it's going to be something over 400. So now we have to concentrate on the numerator. And the numerator is a specific condition that this has to be a real number. All right, so let's tackle that. So we have cos of A pi plus I sine of B pi all to the power of 4. So when they say that it has to be a real number, what that basically means is that we want this I, whatever it is attached to disappear. Otherwise, it's an imaginary number. So I'm not going to expand this out. I'm just going to expand out A plus B to the power of 4, where A is this and B is this. So you can probably do that very easily using the binomial theorem. A to the power of 4 plus 4A cubed B plus 6A squared B squared plus 4AB to the power of 3 plus B to the power of 4. Okay, so now let's talk about this. A is this guy, so we don't need to worry about that because that doesn't have I in it. We only have to worry about the B's because B is what represents that I, the part of the expression that has I in it. Well, here's a B, so we definitely have to be concerned with 4A to the third times B. There's a B here, but it's B squared, and when you square I, it becomes -1, so it's no longer imaginary. Here's a B to the power of 3, and that definitely needs to be taken into consideration. This one is B to the 4th, but when you take I and take it to the power of 4, it becomes 1, and that makes it real. So it's no longer imaginary. So the only parts that have imaginary, the I, is this. So this is what we need to concentrate on. So let's concentrate on that. So we've got this 4A to the power of 3B plus 4AB to the power of 3. Okay. Now we can substitute this for A and this for B. So when we do, let's factor it first, makes it a little bit easier. A, B, and then we'll have A squared plus B squared. Now let's substitute our A and B. Our A is cos a pi, our b is I sine b pi, right? Like that. This is a and this is b. And then in the big brackets, we're going to have a squared plus b squared. So that's cos squared a pi. And then when we square this, it will become negative because I squared is negative 1. So it becomes I sine squared b pi. There we go. So now we have to concentrate on this guy. We want this to equal 0. Now you say, well, why? Well, because if this equals 0, then the imaginary part will disappear. And when the imaginary part disappears, what's left is real. So this whole thing will be real, and that's what we want. Okay? So we want this imaginary part to disappear. How can it disappear? We have a few possible ways. The first is if this cos a pi was equal to 0, correct? If that's equal to 0, the whole thing vanishes. The other way is if sine of b pi is 0, right? And then the third way is if cos squared a pi is equal to the sine squared of b pi. Then that would become 0, this expression here. So let's concentrate on each of these one at a time. All right, so I've got all my values for a or b here. And now let's work with this. So if cos of a pi is 0, this first one, then what does that mean? In terms of a and b, the possible pairings I can get, well, a has to be either 1/2 or 3/2. And b can be anything, any of those 20. So we can pair 1/2 with any of those 20. That gives me 20 possible pairs. And we can pair this 3/2 with any of those 20 b's, give me another 20. So this gives me a total of 40 such pairs. Now let's look at this one. Sine of b pi is equal to 0. Well, what can my a and b be here? Well, a and b can be as follows. The b this time has to be either 0 or 1. And the a can be any of these because a is not part of this equation. So it can be any of those 20 for this guy and any of those 20 for this guy. So that gives me another 20 and 20, 40. So I've got 40 and 40, 80. But not so fast. It's a hard question because those 80 have a few overlaps. There's a few that are counted twice. And those that are counted twice are 1/2 and 0, 1/2 and 1, 3/2, 0, and 3/2 and 1. You'll see that these appear in both sets. They appear here and they appear in here. So we have to subtract those. So since we double counted those, the actual unique number is those 80 minus those 4, which is 76. All right, so far so good. Now we have to concentrate on this guy, and this is a little bit more complicated. First of all, it gives me a couple different scenarios. The first scenario, when we take the square root of both sides, that the cos of a pi is equal to the sine of b pi, or the cos of a pi is equal to negative sine of b pi. And for each of these, we've got to figure out what are the possible pairings for a and b. So here we go. Well, I'll just list them. You can kind of work through these yourself. I don't think you need to hear me talk you through it because that would be very painful. The possible a's and b's are as follows. You can have 0 and 1/2, or you can have 1 and 3/2. And then that takes care of this row. Then the only other ones happen in this row. And those are as follows: 1/4, 1/4, 1/4 and 3/4, 1/4 and 5/4, that was 5/4 and 5/4, and then 3/4 and 7/4. So this is 4 of them. But then we also have 7/4 and 1/4. We have 7/4 and 3/4. And then we have 3/4 and 5/4. And then finally we have 5/4 and 7/4. So we've got all these for this guy right here. Then now, when it's negative, we've got the following for A and B possible combinations that make this work, make that equation hold true. 1.5 and 0 and 3/2 from this row. And now we concentrate on that row, and we get another 8, 3/4 and 1/4, 3/4 and 3/4, 1/4 and 5/4, and then we have 1/4 and 7/4, 5/4 and 1/4, 5/4 and 3/4, 3/4 and 5/4, and finally 7/4 and 7/4. So, exhausting here. How many did we get? We got 10 and 10. We got another 20. So this whole thing, all of these is 20. So we have 20 here, 76 there, so that's a total of 96. So going right back to the very beginning, our probability, remember, was something over 400. Well, that something is 96. And then, of course, they're going to put that in lowest terms. And in lowest terms, it's what, 6/25, I believe? Yeah. So, this question, very challenging. Number 24, the answer is D. A collection of circles in the upper half plane, all tangent to the x-axis, is constructed in layers as follows. Layer L0 consists of 2 circles of radii 70 squared and 73 squared that are externally tangent. For k greater than or equal to 1, the circles in the union from j equals 0 to k minus 1, Lj, are ordered according to their points of tangency with the x-axis. For every pair of consecutive circles in this order, a new circle is constructed externally tangent to each of the 2 circles in the pair. Layer Lk consists of the 2 k minus 1 circles constructed in this way. Let S be the union from j equals 0 to 6 of Lj, and for every circle C, denote by RC its radius. What is the sum of 1 over the square root of RC, where C is element of S? Well, what are they talking about in this question? They want you to figure out all the radii and then add their reciprocals. So, essentially add the reciprocals of the square roots of all the radii of the circles, and that's what basically that means. Okay, so what we want to do is first draw a diagram, and hopefully that diagram will make some sense. Okay, so let's carefully just use the 2 biggest circles and the 3rd circle that's in between them. Now what I did was I wrote the radii basically of these 3 circles, and let's label these now. I'll call this C, I'll call this A, and this is of course C, C, this I'll call B, and this is B, this is A, and this is B. Okay, so now let's try to figure out some sort of a relationship. One line that's going to help me is a straight line across, and another straight line across up at the top. So now let's carefully label this here. this part here, all the way from top to bottom is B, right? And this part from here to here is C. So this is C also, from here to here. So that means from here to here, that distance is B minus C. All right? And therefore, we can now figure this out. And from here to here, I will call that X. I don't know what it is. Okay, so let's use this triangle Pythagorean relationship. So we've got X squared plus B minus C squared is equal to B plus C squared, which is the hypotenuse of that triangle. So this leads to X squared plus B squared minus 2BC plus C squared is equal to B squared plus 2BC plus C squared. So a lot cancels, and in the end we're left with just 4BC is equal to X squared. So that means X is equal to 2 root BC. So I can put that in here, 2 root BC. And then on this side, if we do the exact same thing, let's say that is Y, and I'll let you do the algebra. It's identical. It will come to the same sort of relationship, that it will be 2 root of AC, because those are the variables on that side. Okay? And then this triangle up top here, I'll do that one. It's pretty much identical, but I'll just do it. I'll call that whole distance from there to there, let's say call it L for length, I guess. So that means L squared plus this distance, which is the equivalent of B minus A squared, is equal to the hypotenuse, which is B plus A. And when you expand this all out, you will get that L squared is equal to 4AB, and therefore L is equal to 2 root AB. 2 root AB. There we go. Okay, so now at this point, you will notice something, that from here to here is this plus this, and from here to here, which is the exact same, is that. So we can set them equal to each other. That's very helpful. So when we do, we get the following. We get that 2 root AB is equal to 2 root AC plus 2 root BC. Divide through by 2's, and that just gives me root AB is root AC plus root BC. Now divide everything by the root of ABC. And when you do that, something great happens. You get the root of C is equal to the root of B plus the root of A. All reciprocals. And this is what's going to help us tremendously to calculate everything that we need to calculate in this question. This formula right here. Okay, so now let's go back to that sum. The sum of all the circles, we have to add their radius. We have to take the reciprocal and then add them. So basically, it's 1 over all the circles in layer 1, layer 0 actually, plus all the circles in layer 1, plus all the circles in layer 2, their radii, plus all the circles in radio 3, and so on, right? Radii 4, 5, and so on, dot, 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 dot. Now you say, well, where's layer 0 and layer 1 and layer 2 and all that? Well, the two big ones, those were layer 0s. So this is layer 0 and this is layer 0. The next one was layer 1. So this is layer 1. The next two are layer 2s. This is layer 2, this is layer 2. And then the other ones that are tangent to those two are 3. This is 3, this is 3, this is 3, and this is 3. And then it just keeps on going like that. So I hope to get a pattern, and this is the section, let's see, I'll put any kind of pattern here. Okay, so let's do this now. Let's concentrate on this guy first. 1 over R0. Well, we have two R0s. We have this one, and those are basically as follows. 1 over root A plus 1 over root B. Those are the radii. Okay, great. Well, here we go. This is where the formula comes in. That is equal to 1 over root C. So I can put that in 1 over root C. Well, so far, it looks like that L0 is the same as 1 over root C. Okay, so far so good. Now let's calculate the next one, which is 1 over R1. Okay, now we got to look at layer 1 circles. Well, there's only one, fortunately. So it's just 1 over root C. Okay, that's good. Well, let's go back and add these. So that's 2 now. And then we got this continuation of this nonstop formula. Okay, what is our tally now? It looked like to me that L1 was the same as L0. All right, so far, if I were to, let's say, make a tally, this is going to be just 1. And that's why we had just 1 here. But then when we add these two, it became 2. And that's why we have a 2 here. Okay, so far so good. Nothing earth-shattering yet, but so far so good. Okay, now let's calculate this one, 1 over R2. So we got this 2 root C. The R2s are here and here. Okay, so to get those, we have to keep in mind that they are the sum of the reciprocals of the two tangent circles. So we have 1 over root A, which is this guy, and then we have this guy. So that's 1 over root C, right? That's how it works in this question. And then we have another layer 2, and it's going to be 1 over root B plus 1 over root C. Right? And then these two guys combine, this one A and this B, to give me 1 over root C. So I'll have 1 over root C and then another one and another one. So that's 3 plus 2 is 5. So it's going to be 5 over root C, and then plus the next one, which will be 1 over R3 root. Okay, so that means L2 was actually this guy, which was 3 LO. So that means when you did the summation of all of those, it became 5. And that's why we have a 5 here. Now let's look at layer 3. And layer 3 is this one, this one, this one, and this one. So I'll just write them down here to kind of see. We got the first layer 3, we got the next layer 3, the next layer 3, and the next layer 3. So in a careful way, let's write out each of them. The first one is 1 over root A plus 1 over root A plus 1 over root C. So that takes care of the first one. The second one is 1 over root A plus 1 over root C plus 1 over root C. The next one is 1 over root C plus 1 over root C plus 1 over root B. And the last one is 1 over root C plus 1 over root B plus 1 over root B. All right, so now we can finally combine them. And of course, this keeps on going with 1 over R4 dot dot dot. So this is 5 over root C. How many root C's do we have? 1, 2, 3, 4, 5, 6. So another 6 over root C. And then we've got 1, 2, 3, and 1, 2, 3. So we have 3 over root A plus 3 over root B. And then we've got this continuation. And this combines to become just 3 over root c. So we've got 3 over root c. And then therefore, this can all be combined into 5 plus 6, 14 over root c. Okay, so at this point, it's going to be very complicated to do any more. So we've got to get a pattern here. So L3, it was these two guys, right? So that was 9 L0. So when you added up everything cumulatively, it became 14, and that's why we have a 14 here. So based on this, I conclude that the pattern is multiples of 3. So L4 is going to be 3 times that, which is 27 L0. L5 will be 3 times that, which is 81 L0. And the final one, because it goes only up until layer 6, is 3 times that, which is 243 L0. So if you were to combine all of these, the 6 layers, let's see, it'll be 14 plus 27 plus 81 plus 243, which is 365. So what that means finally is that that big summation of 1 over r for all circles is 365 times 1 over root c. Okay, now we still haven't figured out 1 over root c. Well, if we remember, 1 over root c was equal to 1 over a plus 1 over b. And they had given us in the question that a was 70 squared and b was 73 squared. So 1 over root c is 1 over 70 plus 1 over 73. 1 over root c. So that would be 70 times plus 73 over 70 times 73. Okay, great. So now we can finally figure this out. So it's going to be 365 times 143 over 70 times 73. And when you reduce that to lowest terms, you get 143 divided by 14. 143 divided by 14 is the answer to this very difficult question. And that is choice D.